Hey guys, welcome back to my channel, Logically Literate. In this video I want to show you the beginnings of my project where I'm going to recreate pocket tanks and generate a machine learning algorithm to play pocket tanks. In the next couple of minutes you're going to see the first part of my game building exercise where I've actually recreated pocket tanks. So without further ado, let's get into it. So first thing off, you'll notice I have three different folders here. One's called map, one's called sprites, another is called pygame forms master. This I pulled from GitHub. I'm not going to really talk about it because I'm not actually going to use it, but I will talk about map and I'll talk about sprites. So the way I have this split up is the map and the game itself, and then things that are shown on the map. So sprites are shown on the map, and the terrain and then the actual scoreboard type things are what's shown as the map. Then I have this main file, and that's where actually everything gets kicked off at. So you'll notice inside of map I have scoreboard and I have terrain. All terrain is basically just a class that generates an array of points, and at each point it has a height. That height is the height of the terrain, and then the array itself, each index is an X index. So from the beginning of the screen all the way to the other side of the screen, from left to right, which to you would be from here to here, has a height. And so then what I do is I connect all the heights and I draw a terrain. A terrain has things like helper functions for getting height at a point, getting the grade at a point, so the slope at a point. It has the generation of the terrain, which uses the midpoint displacement algorithm, which is a way to generate smooth terrain. It has an intersects terrain, so every single time a projectile moves or something like that, we can check if it intersects the terrain. And then it has a draw function like every other thing that's in this game. Next up we have sprites. The sprites have characters and we have weapons. Right now we only have a single weapon, and that is the base weapon. All the base weapon is a essentially a way to one, draw the weapon itself, which actually calls character.draw, and I'll describe what a character is in a little bit. It does the update function to actually do the logic of what a weapon would be doing, like did I hit something, did I hit the ground, did I hit the enemy, did I hit myself, things like that. It has a fire function, so you can actually tell the weapon to fire. It has is available, so once a weapon's been fired, it's not available anymore. It has a hit enemy function, so we can check if that weapon has hit the enemy, hit source, and then it has a distance function that kind of abstracts away the calculation of the projectile's distance to a point. And that point could be an enemy tank, it could be the terrain, things like that. And then it has a hit ground function to tell if we hit the ground. And lastly, it has a step fight function that actually does the physics. Next up, we have characters. Characters are the things that are actually drawn on the map. So the difference here is a character is the visual kind of shape, whereas the weapon and then the tank down here inside of the sprite folder is the actual logical thing that the tank does. So if we didn't want to draw anything, we wouldn't need characters, but since we need to draw stuff, we need characters. So there's a tank character, and a tank character has a set cannon angle, get the tip of the cannon function, and then a move function to actually move the tank on the screen. And then it has a draw function. Every character has a move function and a draw function. Move does your movement, so it changes your location. Draw actually displays the polygon on the surface of the game. A tank character has a turret character. Turret character has very similar functionality to a tank. The difference is the turret character is placed relative to the tank on the game map. Again, we have a cannon character, also very similar to the turret and to the tank character. However, it is placed relative to the turret character on the game map. All three together is what is drawn when a tank is drawn. Next up we have the most important thing in the game, the tank. The tank is the central sprite of this game. The tank has a get location function. It has a set target function, so we can tell it what tank to aim at. It has a damage function, so we can check and see how much damage, or so we can set the damage to the tank when the projectile hits the tank. It has an update function, so we can do things like moving the tank, doing some animation, physics, logic, things like that. It has the draw, so it actually can draw its character on the game surface. And then it has a couple of helper functions to load the next weapon, load the previous weapon, move right, move left, increase the angle, decrease the angle, increase the power, decrease the power, and then fire. And then we have a couple private functions like getting the tip of the cannon and moving the tank. This is a generic move that is used in the move left, move right function above. Then we have step animation, which currently isn't doing anything, and then we have an impact callback. So kind of the life cycle of a tank being fired is that a tank is told by a user to fire. The tank then tells its projectile that's loaded as its current projectile to fire given initial power and initial angle. Once the projectile is fired, it's now the responsibility of the projectile to do its own physics and get itself to an impact point. Once it hits the terrain or it hits the tank, it does that check, and based on its proximity to the tank, it does damage to the tank. If it's not close, it doesn't do any damage. If it's close, it does a lot of damage. But once it actually has an impact, it does the impact callback to the tank that fired it. So it has a way of saying, hey, I'm impact and I'm done. What that allows the tank to do is turn off its animation setting such that the game can continue. So basically, once the tank tells the projectile to fire, the projectile fires, and then it tells the tank that it hit the ground or hit whatever. So the tank can allow the rest of the game to continue, and the next player can take their shot. So one thing we need to cover before we get into a demo here of the current state is main.py. Main.py is the launching point for the app. We have a class app here, so it initializes the surface of the game, which is the object that we use to actually draw and render things. It initializes the terrain of the game. It also initializes up to 10 weapons per person of type basic using the base weapon. Then it actually initializes 2 random tank locations kind of on each third side of the game, and then it actually initializes the first and second tank. After that, it sets the target of the tank to the opposing tank, and it generates the scoreboard object. Once this is all finished, it then comes down to the onExecute function, and it calls onExecute. OnExecute essentially, well, rather onInit is called within onExecute. OnExecute is kind of the main entry point for the game. So onExecute does a couple things. It essentially is a glorified while loop, and in that while loop you handle your events, you do a loop function, and you do a render function. So the handling of events is where things like buttons are handled, and things where the user is actually inputting things. Then on loop is the function where we call our update functions. So on loop is essentially the game logic stepping function. Following on loop, once all of the, let's say, numbers have been crunched, on render is called. On render is where all of your draw functionality is called. So every single time it blacks out the screen by filling it with black, and then it redraws the terrain, the tanks, and the scoreboard. And then it calls the update function to actually render that to your screen. So each frame of the game, we're handling events, we're doing on loop, which is calling our update functions for each of our objects, and then we're doing render to actually draw the objects on the screen. So let's go ahead and see what that looks like in practice. So currently this is what the game looks like. I need to do a little bit more work to actually get the scoreboard at the top showing all the data properly, but I want to show what type of weapons currently selected and then the health metric for each tank. You'll notice as I click the up arrow that the cannon on the left is slowly rotating about its axis, or about its vertex rather, and if I hit the down arrow it rotates back. You'll also notice that if I hit the plus or the minus key on my keyboard, the minus/underscore key, you'll see that I am decreasing the power. Similarly, if I hit the plus key, now I am increasing the power. When I hit the F key, it actually fires the projectile. It may have been hard to pick up in the video, but a projectile very fastly just fired across the screen. There's a couple things I need to update still. One's going to be making sure that the projectile moves a little bit slower so it's more visibly pleasing. And secondly is getting the scoreboard finish. But as far as functionally speaking, the game is mostly there. I need to do a little bit more damage logic, and I need to make the scoreboard work better. But that's pretty much it for the game video. If you guys have any questions, go ahead and leave a comment below, and I'll get to that as quickly as I can. Also, my code's going to be on GitHub, and I'll have the link down below in the description. So you can download the game and play around with it, and maybe you can beat me to the punch with the actual implementation of the Q learning. Go ahead and like and subscribe and hit the notification bell so you get notified when I upload my next video, which will be probably about the Q learning, and possibly I'll have an agent to show working. But until then, thanks for watching and have a nice day.